All right, our lesson today is on 8.4, and it's basically, rational expressions. But basically all we're going to do today is a lot of factoring and canceling. So you got to remember your rules for factoring and rules for canceling. Rules for factoring: don't cancel, or make sure that you take out what they have in common first. That's step one. Take out what they have in common. Also, if you have a negative in front, take that negative out. Okay? Look for your special factorings. Square minus square turns into 1 plus, 1 minus, where you square root each. And please, when you cancel, don't cancel things that have a plus or minus by them. So, factoring and canceling, here we go. First one. I hope we're past the point where people are going to be canceling x squareds like this, because that's a colossal no-no. You've got a minus next to the x squared. Don't do that. What should I do first? I should rewrite it. I'm going to rewrite it so that it's in order of degree. So the top one's good, but the bottom one, the degree is 2. So I want to put the negative x squared in front. Now I'm going to look at factoring. Well, the top one, I can take a 3 out. And the bottom one, I can take a negative 1 out. So again, if you have a negative out in front, take that negative out. And then change the signs of everything on that level. That was the denominator there. Now I'm going to continue to factor I have a trinomial on top, a binomial on the bottom. I would encourage you to factor whichever one seems easier to you first. For me, the bottom one I know right away is x plus 2x minus 2. That's a pattern I've seen a million times in my career. The top one, well, that's pretty easy too, but if it wasn't, I would say think about probably canceling at the end. So what's going to happen? What would I need in order to cancel? I need either an x plus 2 or an x minus 2 on top in the numerator. So that can help me come up with my answers for the factors. This one I don't need that help. I just need to know what times what's negative 2 and adds up to negative 1. And that'd be negative 2 and positive 1. Okay, so now we're going to be set to cancel. But before we do that, I want to actually state the restrictions. And the restrictions are just like the discontinuity that we talked about in the previous lesson. It's what makes the bottom equal 0. So restrictions on x would be x can't be negative 2 and 2. Or I could put x can't equal plus or minus 2. So those would be restrictions on that. As far as an answer, now I cancel. And I can leave my answer in factored form. Now I would probably turn 3 over negative 1 into negative 3, but I would leave it in factored form. Okay? So we're factoring and canceling, factoring and canceling. This is the basic one here, where I didn't have to do any other operation. Just had to factor and cancel. Number 2 is multiplication. So I've got actually 2 parts to this problem. A little bit bigger, there we go. They are in order already, and I don't have to take out any negatives, so I'm just going to get right down to factoring. I'm not going to do any canceling right out of the gate here. The bottom right is not factorable. Nothing goes into both of those. The top right, I can take a 3 out. The bottom left is x squared minus 1. That's my good old x plus 1, x minus 1. Square root of both, they have a plus and minus. And the top left needs to factor, or we're going to try to factor, and 12x plus 5 can't be a factor, but you know what? Wouldn't it be cool if x minus 1 works? So I'm actually going to do this. I'm going to say to get 2x squared, I need 2x and I need x. And wouldn't it be nice if x minus 1 was a possibility? I'm just going to try it just to see. If it's going to be minus 1, I need a plus 5 right here. Right? Because then I could go 5 times negative 1, and that's negative 5. Well, now let's see if that actually worked. Check the outsides and insides. I get negative 2x, positive 5x, that's 3x. So that's what it indeed factor into. So by knowing one of the factors on the bottom and thinking that they're probably going to get me to practice canceling, I kind of cheated my way a little bit and got a good start on it. So now I'm ready I'm not quite ready to cancel. I take that back. I haven't stated the restrictions. Make sure you do that before you do any canceling. So my restrictions are, x can't be negative 1. Because negative 1 plus 1 is 0. X can't equal 1 because 1 minus 1 is 0. And then also, x is a problem over here. What makes 12x plus 5 equal 0? Well, that'd be 12x equals negative 5. So negative 5 twelfths. There are 3 x's that don't work. Now I'm going to go back and do my cancel and say, all right, so I had an x plus 1, that canceled an x plus 1. And an x minus 1, canceled an x minus 1. It's too bad I didn't put 2x plus 5 on the bottom right here instead of 12x plus 5. It would have canceled. But it doesn't. It doesn't. So my answer is whatever's left. You can write it in factored form. Stand my page here. There we go. So the factored form on top, you'd have a 3. You have 2x plus 5 on top. So those are the two things that didn't get canceled. And then on the bottom, I'd have this 12x plus 5. So my final answer makes it look like the only restriction would be negative 12 or negative 5 twelfths. But you got to think about the beginning setup when you're coming up with your restrictions, or with the graphs we did in the previous lesson, the discontinuity. Okay, next one's division. Now, division, you got to be careful because you're going to want to come up with your restrictions first. So let's actually factor this first. I'm going to put this over 1. And I see I can factor the top right pretty easily by taking out a 3x. That would leave me with x plus 9. On the left, what times what's negative 27 and adds up to 6? What times what's negative 27 and adds up to 6? Well, positive 9 and negative 3 would get me negative 27 and add up to 6. And so what are my restrictions? Well, right now, x plus 5 is in the denominator, so x can't equal negative 5. But guess what? How do you divide? Well, you multiply by the reciprocal. That's how you divide fractions. So I'm going to leave this first one and multiply by, flip the second one over. And now it looks like negative 5 would have been fine, but it wasn't in the first place. So negative 5 is a restriction. But now what else is a restriction? What else caused a problem? Well, 3 times 0 would be bad down here. So that would make the denominator equal 0. And negative 9 would be bad right here because if you add negative 9 to 9, you get 0. So there are actually 3 x's that are bad here, all caused by the second part of the problem. Well, we've already got it all factored, so we actually just need to cancel. I got an x plus 9 on top. I got an x plus 9 on the bottom. I can't cancel anything else. I can't cancel this 3 with the 3 up there because the 3 up top's got a minus 3. So I just go ahead and write my answer with whatever's left. I got an x minus 3. Careful here, you better put that x plus 5 in parentheses. And then the 3x's on the bottom. My final answer would only have a restriction of 0, but truly the whole problem's got restrictions of -5, 0, -9. So if I ask for restrictions, you'd have to give me all 3 of those, even though they cancel out. Last problem, got multiplication and division. So let's see here. It's going to be over 1. I'm going to think about what would cause a problem in this denominator. This one I'm going to have to flip over, right? And I can factor everything right now, but I'm thinking, what would cause a problem over there? And right now, 3 times what minus 21 is 0. X can't be 7, right? So that's the one that's going to change. That's the one I might miss if I don't put a restriction down right away. I might forget that, I take a 3 out of here and X can't be 7. So now before factoring, I'm actually going to rewrite this thing. If you want to factor it first, go ahead. It's perfectly fine. 6x plus 9, that stays over 1. That doesn't change. But this last one's going to flip over. And I'll write it in factored form since I already took the 3 out. So that's my problem. I turned it into a product of 3 expressions. Now I'm going to factor. I truly hope there's nobody out there that's thinking, I'm going to cancel these 2x squareds. That needs to be a thing of the past. That's a no-no. The top one's got a plus by it. The bottom one's got a minus by it. Please don't be that guy. So we're factoring. I already took the 3 out on the right, but I could also have taken a 3 out right here. I got 2x plus 3. So why did I save the factoring? Well, the reason I saved the factoring is I'm looking, let's look at the top. I got 2x squared plus x minus 15. And on the bottom over here, I got 2x minus 5. Well, it looks to me like 2x minus 5 has a chance at being a factor up here. So I'm going to try it because, there's a pretty good chance we're trying to do things that will allow us to cancel. So I'm going to use 2x minus 5, and if it's 2x minus 5, this would have to be x. Because 2x times x is 2x squared. And this would have to be plus 3, because negative 5 times positive 3 is negative 15. The question is, does it work in the middle? So we got to check the middle. Plus 3 back in here. And make sure that we do in fact get positive 1. And I get 2 times 3 is 6. Negative 5 times 1 is negative 5. That gives me the positive x I'm looking for. So that's what the top factors into. Okay, the bottom. Well, let's see, the bottom. What's on the top that can go into the bottom? I think 2x plus 3 could go in the bottom, because 2x could be made into 2x squared, and 3 could be made into negative 21. It also could be x minus 7, because 2x times x is 2x squared, and 3 times negative 7. Wait a minute. Wouldn't it be nice if it was both these, then I could cancel both? Let's try that. So if this was 2x plus 3, and then would x minus 7 work? I get 2x times x is 2x squared. I get 3 times negative 7 is negative 21. So it's down to the middles. Do the middles work? Negative 14, positive 3. Negative 4, that's negative 11. That's what I want. So this does, in fact, factor into 2x plus 3x minus 7. So my point is, if you have a factor that you know in a numerator or denominator, you might want to say, hey, can I use that in something that needs to be factored? Because there's a pretty good chance we're going to be canceling. So, what cancels? That was the fun part. Oh, wait a minute. I got ahead of myself. I shouldn't say what cancels because I still haven't got all my restrictions. I almost forgot all my restrictions up here. I initially had the 7. But what else is there? Well, this is in the denominator. That can't be 0. 2x plus 3 is in the denominator. That can't be 0. So what makes 2x plus 3 equal 0? Well, that would be negative 3 halves. So x can't be negative 3 halves. Anything else in the denominator? Well, this is the denominator, but I already got that one covered. I already did x minus 7. So I already have 7 accounted for. Well, here's another one over here, though. I got the 2x minus 5. That can't be 0, because then it wouldn't work. So that'd be 2x equals 5. That'd be just 5 halves, right? So those are my restrictions. 7, negative 3 halves, 5 halves. The things that make each denominator equal 0. But remember that if you have division, you have to start by saying what makes this first denominator equal 0 before you flip it over. So let's get back to the canceling. The fun part, I got a 2x plus 3 in the bottom and a 2x plus 3 in the top. I got an x minus 7 on the bottom and an x minus 7 on the top. I got a 2x minus 5 on the bottom and a 2x minus 5 on the top. What am I left with? Well, nothing on the bottom. Everything canceled except for the 1. On the top, I got x plus 3, I got 3 and 3. So I'm going to multiply those together, and that would give me 9. 3 times 3 is 9. I put these together. And then this was left. And you can leave it in factored form, or if you want to turn it into 9x plus 27, either one of those are good answers.